Alright, welcome. In this video we're going to practice completing the square. We're going to work on Algebra 2 Homework 4.2. So it starts off with a couple of just like solve the equation. And that's something that, I probably should show you how to do in a quadratic unit, but I don't really have much to do with completing the square. So we'll just start off with those, then we'll do some complete the square examples. Okay, so the first one, problem is x plus 2 squared equals 36. Okay, if two things are equal, then their square roots are going to be equal, right? I want to get rid of this squared by taking the square root of both sides. Okay, so I'm going to take the square root of x plus 2 squared, and that's going to be the square root of 36. Okay, now the square root of something squared, that's the absolute value of it. Okay, so this is going to be the absolute value of x plus 2 equals 6, because the square root of 36 is 6. And then we know how to solve this equation. If the absolute value of something is 6, then that thing is either 6 or that thing is negative 6. Okay, then I'll subtract 2, and then I've got my solutions. Okay, and then you can go back and check, and you can say, okay, 6 squared is 36, and negative 6 squared is also 36. The second one of these is x minus 3 squared equals 5. Okay. And, okay, so I'll do the exact same thing. I'm going to take the square root of both sides. And then I'll say, okay, this is the absolute value of x minus 3. That's equal to the square root of 5. That means that x minus 3 equals the square root of 5, or x minus 3 is the negative square root of 5. Okay, and then I'll add 3 to both sides of both equations, and I'll get x equals 3 plus square root 5, or x equals 3 minus square root 5. And this is where the plus or minus comes from in the quadratic formula. And I know we haven't talked about that yet, but we are going to, right, in a couple of lessons. All right, now we're going to solve an equation by completing the square. Okay, so pretty much what this is this is where we're solving the equation by completing the square, but just the square was already completed for us. Okay, so we're just going to have to start by getting it into a form like this that we can then use to take square root of both sides for these solve the equation by complete the square problems. All right, so we got x squared plus 2x plus 7, no, minus 7 equals 0. And I'll just erase. Okay, positive 2x minus 7. Okay, so the idea here is that we need to turn the x squared plus 2x into a square, and I'm going to do that by adding the same number to both sides of this equation. Okay, and then I'll like work some stuff around. Okay, so I know that I'm going to have x squared plus 2x plus some special number that's going to make this a square minus 7 equals 0 plus that same special number. And I get that special number by taking the number of x's, so that 2, dividing by 2, and then squaring. Half, then square. So I'm going to take 1, I'm going to square it, and I'm going to get 1. Okay, so I need to add 1 to both sides. Okay. And then I factor the thing in parentheses. So this is going to be x plus 1 times x plus 1. Okay. And maybe I'll say minus 7 equals 1. Then I'm going to add 7 to both sides to get it kind of looking like this one. And then I'm going to take the square root of both sides. Okay, if you want to simplify the square root of 8 into 2 times the square root of 2, you can definitely do that. Okay, but we haven't really studied radicals in this class yet, so I'm not going to expect anybody to simplify this because that's not something that we've done yet. It's not something I've explicitly told you how to do, so I'm not going to expect you to just know how to do it. All right, so I've got absolute value of x plus 1 equaling square root of 8. And, maybe I'll switch it up and, the way I solve this, and I'll say, okay, I know that the absolute value of x plus 1 is equal to square root of 8. X plus 1 is either positive or negative square root of 8. And then we get x equals negative 1 plus or minus the square root of 8. Okay, which I could say if I wanted to list out both solutions, that would be x equals negative 1 plus the square root of 8, and x equals negative 1 minus the square root of 8. And that's how we solve by completing the square. So there's nothing on the back, so I might as well work on it. So number 3, that's x, no, we already did number 3. Okay, 2x squared minus 8x minus 22 is equal to 0. Now on this one you got a couple options. You can factor out the 2 and do the way I showed you when you have to complete the square with a not 1 leading coefficient. Let me make sure there's going to be some of that happening later on in the homework. Yeah, there is. So I'm going to just kind of choose to not do that. So because you can divide both sides of an equation by a number, right? So I'm going to divide everything by 2, and that will be the same equation as 1x squared minus 4x minus 11 equaling 0. And we've got a quadratic set to 0. I didn't even mention this the last time. We should probably check to make sure it's not factorable, even though it says complete the square. It's much easier to solve something with factoring. But I can't think of any factors of negative 11 that would add to negative 4. It's just going to be 11 and negative 1 or negative 11 and positive 1. And neither of those are going to add up to 4. So we have to complete the square. So now I'm going to kind of leave a space to add the same number to both sides. Okay, and I'm going to find what number I want to add to both sides by taking this negative 4, dividing it by 2, and then squaring it. Okay, so that's negative 2. Negative 2 squared would be positive 4. So I'm going to add 4 over here and 4 over there. And then I block off this thing because it's now factorable as a perfect square trinomial. And now I've got x minus 2 times x minus 2, two numbers that multiply to positive 4 and add to negative 4. So 2 copies of x minus 2 minus 11 equals 4. Okay, and then I'm going to add 11 to both sides. Okay, then I'm going to take the square root of both sides. Okay, and this is going to be the absolute value of x minus 2. And then okay, I'm going to say x minus 2 is plus or minus the square root of 15. And then I'll solve for x by saying x is 2 plus or minus the square root of 15. All right, so I could have x equals 2 plus the square root of 15, or x equals 2 minus the square root of 15. Okay. Okay, that'll be good. Then, okay, what was I thinking? That was just number 4. Okay, yeah, there's one more. All right, x squared plus 3x minus 5 is equal to 0. Oh, okay, so this one, okay, there's one of these on here. I try to avoid this situation where the b is an odd number because then the number you have to add to both sides is a fraction, and it's kind of annoying. But it's probably good that we do it once. And, you know, if you're here, I'll tell you this is not the type of thing I'm going to ask you to do on a quiz or a test. But it's good for homework, and it's good that we've at least seen what happens when b is not an even number, because it's pretty much always going to be in my class at least. It's just the numbers turn out bad if it's odd. So what we're going to do is the same thing. We're going to check for, is it factorable? The only factors of 5 are 5 and 1. So it would be positive 5, negative 1 doesn't add to 3. Negative 5, positive 1 does not add to 3. Okay, it's close. If this was 4, we'd be in business, but it's not. So what we're going to do is we're going to do the exact same thing. We're going to add some space to add the same number to both sides of the equation. Figure out what number I need to add to both sides of this equation by taking this positive 3, dividing it by 2, and then squaring it. Okay, so if I square 3 halves, that's 3 halves times 3 halves, that's going to be 9/4. And then I need to add 9/4. You know, and since I know I'm eventually going to have to add the 5 over to the other side, I might just rewrite it as 20 over 4 because, you know, I need a common denominator to add these things together. So I'm going to add the 20 over 4 to both sides. And I guess factor this thing. Now, what it's going to be is it's going to be x plus 3 halves squared. Okay, you can check that with FOIL or mentally or whatever you need to do, but that's how it's going to factor. And I'm going to add, maybe I'll, okay, and then I'm going to add the 24ths to both sides. and then I'm going to take the square root of both sides of this equation. All right, and then I'm going to say, all right, maybe I'll just say the absolute value of x plus 3/2, because I've done that a bunch of times already in this video. I've taken the square root of a square thing, and I've turned it into the absolute value. Okay, and that's going to be the square root of 29/4. Now, if you know that, we can take the square roots of top and bottom separately, because that's a radical property, and we can say that's the square root of 29 divided by 2, good for you, right? You want to call that root 29 over 2, be my guest. I'm going to continue to call it square root of 29 divided by 4, because, again, we haven't studied the radicals yet, so I'm just going to the only thing we're going to do is take the square root of a number, right? And if it's an obvious square root that we've seen before, like square root of 49, maybe I'll take that. Otherwise, I'm just going to leave it be. So I've got x plus 3/2 equals plus or minus the square root of 29 over 4. Right? Because the absolute value equals that square root. So the number itself has to be plus or minus that. All right, and then I'm going to say x equals negative 3/2 plus or minus the square root of 29 over 4. And so if you wanted to write that, you could say x equals negative 3/2 plus the square root of 29 over 4, and x equals negative 3/2 minus the square root of 29 divided by 4. All right, so good, completing the square. All right, write the quadratic equation in vertex form and sketch its graph. So we've got f of x equals x squared minus 4x plus 13. Okay. So it's the same thing. We're going to complete the square to hopefully write this in vertex form, which I'm going to kind of copy off to the side over here. Okay, that's y equals some number times x minus h squared plus k, where the vertex is at the point h and k. Okay, so that's what we're going for. So in order to write this as something squared, we're going to have to complete the square on the x squared minus 4x. Okay, so what we're going to do is we're going to say f of x, and I'm going to leave room to add the same number to both sides, which is, I will admit, people in my first period class, that's not what I did in the lesson, I know. But I determined in second period that it was clearer to most Algebra 2 to just add the same number to both sides of the equation rather than adding a clever form of 0. Well, I hadn't taught Algebra 2 for a few years, so I just had to experiment, and it turned out that adding the same number to both sides was much more comfortable to students, it seemed like to me. So x squared minus 4x, we're going to add in some number over here, and then it'll be plus 13. All right. And that number that we're going to have to add to both sides, I'm going to take that negative 4, and I'm going to divide it by 2, and then I'll square it. Okay, and then that will be the number that I put back over here. So negative 2 times negative 2 is positive 4. Okay, but I'm going to need to add 4 over here as well. Okay, now I'm going to factor this thing. That's the whole reason I added the plus 4 was so this would become a perfect square. It's going to be x minus 2 times x minus 2. And I'll have f of x plus 4 over here. Okay. Now I'm going to subtract 4 from both sides to get rid of that. And I'm going to solve for f of x, and that's going to be x minus 2 squared. 13 minus 4 is 9. Okay. So I've got my vertex form, right? Because f of x, that's just code for y. And in this case, a is 1. My vertex is 2 and 9. Okay, so since the leading coefficient is 1, I know it's going to open up and be kind of a standard width parabola, whatever that means. So I'm going to draw myself whatever I think a standard width parabola is. I'm going to label the vertex. And okay, I could see from the original thing that the y-intercept is going to be 13, but I think that's a decent sketch. It's vertex form, so we're focusing on the vertex, and I don't think you necessarily need to, drawing the axes like down there. I don't think that's necessary. Right. 7. H of x equals 9x squared plus 18x minus 3. Plus 18x minus 3. Okay, and I'm going to complete the square on this thing just like I did with the other one. So I'm going to leave some room to add something to h of x, and I'm going to factor out this 9. But only from the things that have an x in them. Okay, and then I'm going to leave space to turn this into a perfect square, and then I still have that minus 3. I haven't changed that. Okay, so now I have to think about what number I'm going to add here to make this a perfect square. I'm going to take that positive 2, and I'm going to divide it in half. And then I'm going to square it. Okay, so I have negative 1 times negative 1. That's positive 1. Okay, now I have to be fair to both sides of this equation. I have to think, what did I really add? I didn't just add 1, right, because of that 9. I added 9 times 1. So I would need to add 9 over here as well to be fair to both sides of the equation, not change the function. Okay, now I'm going to say, okay, this is h of x plus 9 equals 9 times, and then the thing in brackets I can factor. That's going to be x. I don't know why I put negative there. That caught my eye. I'm seeing positive 2 here, positive 18x on the original copy of the homework. I'm not sure what I was doing there. Yeah, positive 2 over 2 squared. Doesn't really matter, but it does matter if you're using this number to determine what's supposed to go here. Okay, so that would be plus 1 squared minus 3. Okay, now I'm going to subtract 9 from both sides to solve for h of x. That'll be 9 times x plus 1 squared. Negative 3 minus 9 is negative 12. Okay. And then I go over here, and I'm going to sketch it. Okay, so my vertex, I should write that out. Okay, the x coordinate of the vertex is whatever makes this thing in parentheses equal to 0. Okay, because of max-min reasons that I'm probably going to get into it the next time. But vertex is going to be where x is negative 1 and where y is negative 12. Because if you think about it, when x is negative 1, 9 times something squared is always either 0 or positive. So the very minimum that this whole total can be is going to be where this thing comes back 0. And the minimum happens at the vertex. Okay, so when this is 0, I know I've got 9 times 0 minus 12, and that's going to be the minimum value of y is going to be negative 12. Okay, that's, I think, enough. I'm going to draw a very narrow parabola that opens upward because of that positive 9 times x plus 1 squared. Okay, and I'm going to label the vertex. That's at negative 1, negative 12. Okay, if we'd done the work to find the x-intercepts of this thing, which I can tell there's going to be 2 x-intercepts because it opens up and its vertex is below the x-axis. So I know it's got to be somewhere. But that's not the work that we did, so I'm not going to label that. I'm not going to do extra work, right? Because it's just write the equation in vertex form and sketch the graph. Okay, but that was a good example of completing the square where the leading coefficient wasn't 1. We had to be careful about what we were adding to both sides, and it didn't look like the same number, but we were adding the same amount to both sides of the equation. All right, now a little bit more solve the equation by completing the square. Okay, I thought we were done with that. I honestly kind of hoped we were done with that, but it's back, so it'll be all right. Number 8. X squared plus 8x is negative 15. Okay, I'm just going to immediately leave room to add the same number to both sides. All right, I'm going to take, this one was factorable, so if you had added 15 to both sides, you could have solved this one by factoring. Now, it says solve by completing the square, so I'm going to do that. But if you're working it at home and you're like, man, I'm going to factor that because I'm good at that, then you should do that, totally. Okay, I'll make sure to give you ones on the quiz, I guess, that are not factorable, okay, so that you have to use complete the square. Okay, either way, I'm taking this positive 8, and I'm dividing it by 2 and getting 4, and then I'll square it, and that'll be the number I need to add to both sides. So that'll be plus 16 and plus 16. Okay. So I can factor this. This is going to be x plus this number squared equals 1. Okay. And then I'm going to take the square root of both sides of this equation. And so I'll get the absolute value of x plus 4 is equal to the square root of 1, which is 1. Maybe I'm going to put that in there just to be really clear. And then I'm going to say, okay, well, that means that x plus 4 is either 1 or x plus 4 is equal to negative 1. I'm going to subtract 4 from both sides. And I've got, two x values that are solutions to this equation. Looks like somebody got a paper out of my ream of printer paper. So that's not supposed to happen. Okay, how much more printer paper do we have? Okay, I need to get rid of the printer paper. Yeah, everyone knows printer paper belongs to the printer, not for scratch work. So number 9, x squared plus 4x equals 8. All right, so we're going to leave the space to add the same number to both sides. We're going to figure out what number we need to add by taking that positive 4, dividing it by 2, and then squaring. Okay, 2 squared is 4. Okay, and then, okay, it's going to be x. Okay, because this was positive 2, it's going to be x plus 2 squared equals 8 and 4 is 12. Okay. And then, just, because you've watched with me this long, I'm going to be a little more explicit about what that number is. It's always that thing. Okay. And then I'm going to say, all right, take the square root of both sides of the equation. X plus 2 squared square rooted is the square root of 12. The square root of x plus 2 squared is the absolute value of x plus 2. Okay, if the absolute value of x plus 2 equals root 12, then x plus 2 itself is either positive or negative square root of 12. Okay, and then I'm going to subtract 2 from both sides. And then, okay, I've got two solutions. Negative 2 plus the square root of 12 and negative 2 minus the square root of 12. And that's great. All right, number 10. All right, 5x squared plus 10x equals 130. And maybe I'll do this when maybe you don't see that all three of these numbers are divisible by 5, and you're just going to complete the square by factoring out the 5 here. And you can do that. So I'm going to show you how you would if you just didn't see that you could divide this whole equation by 5. 2x plus something equals, all right, what we got there. And that's not what I was expecting. I thought this one was factorable. I remember making this problem. I made an arithmetic error or something. But the thing is that it doesn't matter if it's factorable or not. We can always solve by completing the square. That's kind of one of the morals of today's lesson. Okay, so 5 times 1 is going to be 5. 5 times 2x is 10x. Okay, yeah. I'm going to take this 2, whoops, and take positive 2 divided by 2 and square it. Okay, and that's going to be 1 squared is positive 1. So I need to add 1 to both sides. Oh, whoops, I still have that 130 over here. And then I'm going to add 5 times 1 on this side to be fair to both sides of the equation. Because really, if I was to distribute this back out, I'd have 5x squared plus 10x plus 5. So I've added 5 to this side, I got to add 5 to that side. Okay, so 5 times something squared, that would be x, okay, plus this number here, which is positive 1. Okay, and that's going to be 135. Oh, no, it is going to work out. We just have to know what 135 divided by 5 is. Oh, no. Okay, well, we're going to get at x by first getting rid of the 5, then taking the square root. I got to think, okay, 135 divided by 5. I do know what it is. Okay, dividing by 5 is like dividing by 10 and then multiplying by 2. Okay, so 270 divided by 10 is going to be 27. Okay, you could also do long division, but I'm pretty error prone with long division, so I'm best to just kind of think about it. Yeah, and 20 times 5 is 100, and 7 times 5 is 35, so that's confirming it to me. Unfortunately, 27 is not a square number. Yeah, I think that's where I made the arithmetic error. I don't know what I was thinking. 27 is a cube number, but that's fine. So I'm going to take the square root of both sides of the equation. I'll get x plus 1 squared's square root equals the square root of 27. Okay, that's the absolute value of x plus 1 equaling the square root of 27. And that's going to happen when x plus 1 equals the square root of 27, or when x plus 1 equals the negative square root of 27. I'm going to subtract 1 from both sides. And there, I've got it. Okay, that was number 10. What else we got on this homework? Write the equation in vertex form, sketch the graph, determine where the function is increasing and decreasing. Okay, sketch the graph, find the maximum and minimum value. And then there's going to be 6 more. Oh man, we're only halfway there. This is a robust homework. Hopefully, you've embraced my message that, on any of these homeworks, once you getting it, once you're like, okay, I am good. I understand what I'm doing here. I know you can stop watching the video. You can stop doing the problems. You can stop practicing because you've practiced enough, because you're confident. We practice until we feel good. Okay. So number 11. I might start to go a little faster through the complete the square step. F of x, I'm going to add the same number to both sides, so I might as well leave a space for that, x squared minus 20x. Okay, I'm going to add the same number over here, so I'll leave a space, and then plus 1. Okay, I'm going to determine what number by taking that negative 20, dividing by 2, and squaring. Okay, so that'd be negative 10 squared is going to be 100, so I need to add 100 to both sides. Okay, then I'm going to factor this thing. Okay, and it's going to be x plus negative 10, so x minus 10 squared plus 1 equals f of x plus 100. Okay, I'm going to subtract the 100 from both sides. F of x equals x minus 10 squared minus 99. Okay, and then I'm going to, what was I thinking? Oh yeah, I'm going to sketch it. Sketch the graph, give the intervals over which the function is increasing and decreasing. Okay, it's going to open up because it's 1x squared. The vertex is going to be at 10 and negative 99. Okay, got myself a parabola there. And that's going to be good enough for me to tell where the function is increasing and decreasing. Okay, increasing is where the function has a positive slope, whereas I move left to right, the graph is going up. So that would be right here. So increasing is from x equals 10 on to x equals infinity, or not, oh, pardon me, I can't believe I almost said that. X can't equal infinity. Infinity is not a real number. Equals is only a relationship between two real numbers. So I'm going to say increasing from x equals 10 on, so x is greater than 10. If you want to write these as intervals, be my guest. I'll write them as intervals in the next problem. Okay, and then decreasing, okay, that's where it's got a negative slope. That would be here. Whereas I move left to right, the function is going down. The graph of the function is going down. So this would be where x is less than positive 10. Okay, and yeah, okay, I think that's all I've got to say about that, right? It was sketch the graph, give the intervals of increase and decrease. We did that. Let's move on. Right. Number 12. Oh, whoops, I didn't leave any room. Okay, so I'm going to figure out, oh, no, I've got that negative. Okay, and that's, okay, good that I've got one of those on there too. I'm going to treat the negative just like when it was 2x squared and or 3x squared and I had to factor it out or something. Or if this was 7x squared, I'd have to factor out the 7 from the x squared and the 14x. I'm going to factor out the negative. Okay, so okay, I'm going to leave room to add the same thing to both sides. I'm going to factor out the negative from x squared and positive 14x. Okay, I'm going to leave room to add some number over here, and I still have a minus 10. And I'm realizing that's probably out of view. All right, so I'm going to say, okay, what number do I need to add add in here to complete the square? That's going to be negative 14 divided by 2 squared. Okay, so I'll put that over here. Negative 14 divided by 2 squared. Okay, that's negative 7 squared is positive 49. Okay, but you got to be careful here, right? What I really added was a negative 49. So I need to subtract 49 here as well. Okay. And then I'm ready to factor. Okay, this is going to be x minus 7 squared minus 10. Okay, I'm going to add 49 to both sides. And I'll say, all right, g of x is going to equal the negative of x minus squared plus 39. Okay. And now I've got a vertex at 7 and 39. And it's going to open down because I've got a negative x squared, negative leading coefficient. Okay, that's going to be my parabola. And, intervals of increase and decrease. Okay, g is increasing where its slope is positive, where as I move left to right, the graph is going up. Okay, so that's from negative infinity up to 7. Okay, so increasing for negative infinity up to positive 7. Okay, if you want to make that a square bracket, you are fine to do that. It actually doesn't matter. It depends on your definition of increasing and decreasing. And it's going to be decreasing where the slope is negative, or where, as I move left to right, the graph is going down. So it's going to be from 7 to positive infinity. Okay. The next two, write the equation in vertex form, sketch the graph, find the maximum minimum value. Okay, now I'm going to determine what number I'm going to add to both sides, and I'm going to take that positive 12, divide it by 2, and square it. Okay, so that'll be 6 times 6 is 36. So I know I need to add 36 to both sides of this equation. Here's where I'm adding the 36. Okay, and then I've still got this 46 over here. Okay, and then this thing in brackets, this is going to be x plus this number squared, so x plus 6 squared. And you should probably, like, when you do this factoring step, just check real quick to make sure it's going to work. So x plus 6 squared. And I'm checking that by, envisioning myself multiplying x plus 6 times x plus 6. I'm going to get an x squared. I'm going to have outside and inside both being 6x, so they would combine to 12x, and then 6 times 6 is 36. So, okay, I'm right here. I feel good about that. And everything else has stayed the same. Okay, now I'm going to subtract 36 from both sides. Okay. And, okay, now I think I should probably sketch the graph to, help me draw these conclusions about maximum and minimum value of f. Okay, so this is going to open upwards because it's got this positive 1 times x plus 6 squared. The vertex is going to be where x is negative 6 and y is 10. And it's going to open up like that. Maybe a little flat in the middle, but it's fine. It's just a sketch, right? So I'm going to say, all right, find the maximum or minimum value of f of x. Remember, f of x is like standing in for y. It means y. So if we're looking for the maximum value of y, well, I mean, these arrows are indicating that this thing goes on forever. Like this, we can make this thing get up as high as we want just by choosing values of x that are, I guess, far enough away from -6. The minimum value of f happens right here, and the value of f is f of -6 equals 10. So I'm going to say that the minimum value of f of x is, you could say is 10, or we could say is f of -6 equals 10. But really, the 10 is the value of f, because it's the y coordinate. All right. Number 14. Yeah, this one's going to open down, so we'll have a maximum. So this one, f of x equals -2x squared minus 36x minus 170. Now this is not, okay, well, I mean, you can divide both sides of this equation by -2, but you would need to hold on to f of x divided by -2 and then multiply it back, and I don't think that's the way to go. Okay, if we're just solving an equation, the solutions to the equation are not changed if we do the same thing to both sides of the equation. But a function could be changed, like if you were just like, oh, I'm just gonna make this -x squared minus 18x minus 85, well, then you would, I think, and I feel like that's factorable, but either way, what am I saying? It's like, hold on. If you were to divide this thing by -2, you'd have another parabola, and it would have the same zeros, but it would no longer open downwards and be super narrow. It would have, like, you'd change the location of the vertex, you'd change the maximum or minimum value, and the fact that it was a maximum or a minimum. So we're not going to be able to do it. That's not going to be an algebraically legitimate thing to do. And so we're going to factor out the -2. So I'm going to leave room to add the same thing to both sides. And I'm going to factor out the -2, and I'll be left with x squared plus 18x. Okay, I'm going to need to leave room to add, another number. And then I have minus 170, because I did not factor the -2 out of the -170. I'm just factoring it off of the things with the x's so I can, be as clear as possible about what I need to add here to make this a perfect square. What I'm going to add is I'm going to take that positive 18, I'm going to divide it by 2, and I'm going to get 9, and I'm going to square it, and that will be 81. Okay, so plus 81. But the thing is, if I added 81 over here, I really added to this side of the equation a -162. So I need to add a -162 to this side as well. And then I'm going to add 162 to both sides of this equation, I guess, while also factoring this. Okay, so this is going to be x plus 9 squared. And then if I add 162 to -170, I think I'll have minus 8. Yes. All right, and now I've got it written in vertex form. So I'm going to sketch the graph. Okay, so the vertex is happening at where x is -9 and where y is -8. And this opens down and is kind of narrow, so I'll just label that vertex. That's a pretty good one. And okay, I can see that the maximum value is happening right here, and it's a maximum value of -8. But I feel like I've got more to say about this. If x is -9, okay, so you've got -2 times a square number. Okay, if I'm just thinking about that x plus 9 squared, that thing is either 0 or it's positive. You square anything besides 0 and you get a positive number. So if I take this positive number and I multiply it by -2, I always got a negative number. So this total is almost always less than -8, because it's -8 minus 2 times a positive number. Okay, so the most it could possibly be would be where -8 minus, and so that would be why another reason why the maximum value of f is -8.
negative 8.
Okay, and that was a good example. Now, on the back, we got ourselves a few more. But this is one where it's like kind of the whole laundry list of things you're supposed to find. Okay, I prefer to just ask you about one thing at a time. Okay, I don't like the problems where it's like find the vertex axis, intervals of increase and decrease, maximum value, direction of opening, focus directrix. We don't know about that yet, but we will soon. I'm going to try to, as much as possible, just ask you about one thing at a time so that I can tell, do you actually know what each of these things are individually? Okay, so I'm going to go and I'm going to do these definitely on a separate sheet because I write pretty big and I like to space out my work. But these on the back, these 6, I put these on there for more practice if you felt like you needed more. If you feel like I'm good at this point, you can feel free to stop working, right? If you feel like you've done everything. Because there's nothing new on this backside. This is just more practice. All right, I think that's enough of my spiel. F of x. Nice, this is already in vertex form. Oh, these are all already in vertex form. Okay, change of plans. I thought I was going to need to complete the square on all 6 of these, and it looks like that's not going to be necessary. So I'm just going to get a scrap of paper and work each of these on a scrap. No, I lost my notes. All right, number 15. All right. Well, I think I'm going to sketch this. I always start with a sketch, and if you don't want to sketch, then fine. Okay, but it opens down. It's got vertex at 2 and negative 4. It's got a coefficient of negative 3, so that's pretty narrow. Okay, so the vertex is at negative 2 and negative 4. Axis of symmetry is going to be the set of all points where x equals 2, right? It's that. Okay. Intervals of increase and decrease. Increasing from negative infinity up to 2. Okay. And it's decreasing from 2 to positive infinity. Okay. They're also asking for the maximum and minimum value. Okay, so the maximum of this thing is happening at x equals 2 and y equals negative 4. It asks for the maximum value of the function. So I'm going to say the maximum value of f and that's negative 4. Okay, and that's all they're asking for, right? Vertex, axis, increase, decrease, min. Okay, and there is no min. Right, number 16. Right, negative 1/4 of x minus 1 squared plus 4. Okay, so the vertex is going to be at positive 1 and 4. Okay, so we'll just draw that. It's going to open down because of the negative, but it's going to be relatively wide because of the coefficient of 1/4. That's pretty okay. I have a harder time drawing the wide ones. And, okay, we've got a vertex. Axis of symmetry is going to come down through here, and that's going to be x equals 1. The intervals of increase and decrease is, okay, it's increasing from infinity up to x equals 1. So I'm going to say x is less than 1. It's decreasing where x is greater than 1, right? Because it's got a negative slope, or as I go left to right, the graph is going down. It's going to have a maximum value of f is up here at the top, and that's the y-coordinate, that's 4. Okay, and then number 17, I guess maybe I can get a little bit more mileage out of this scrap of paper. Number 17, 1/4 of x plus 4 squared plus 3. That's going to open up and be pretty wide. So I'm going to draw it like that. Label the vertex. That's where x is negative 4 and y is positive 3. Okay, so that'll be my vertex. Okay, the axis is going to be all of these points, okay, the set of all points where x is -4. Okay, the minimum value of the function is going to be 3. I'll just do that first, since it looks like I'm stacking up that way. Okay, the function is increasing over here where x is greater than -4. Greater than -4. And it's decreasing when x is less than -4. Okay. And then number 18. F of x is positive 1/4 of x plus. This is the exact same problem. Okay, whatever. I clipped it from a textbook. That's what you get when you clip from a textbook, right? You're going to have repetitive problems. There's no sense in being upset about it. I should have proofread before I just made the copies and handed out the homework. So, okay, this vertex is going to be at x equals -5, y equals +2. Okay. Axis of symmetry is right here. That's a vertical line. It's the set of all points where x equals -5. The function is increasing when x is greater than -5, so maybe -5 to +infinity. Okay. It's decreasing when x is less than -5, so maybe -infinity up to -5. And then the minimum value of f of x is going to be 2. Okay. The last two, 19 and 20. Right, -2, okay, means the parabola is going to open down and be kind of narrow. It's a little pointy there, but, you know. Okay, it looks a little better now. Smoothed it out. Okay, the vertex will be where x is -5 and y is -3. Okay, the axis of symmetry is going to be this right here, the set of all points where x is equal to -5. F is increasing up until -5, so I might say that's -infinity up to -5. And it's decreasing when x is greater than -5, -5 to +infinity. Okay, need a little more room over here. Nope, didn't find the maximum value. The maximum value of f is going to be -3. And then x plus 2 squared minus 1. Okay, so that's positive 1 there, so it's going to open upwards and be, you know, standard width. And, okay, what was I thinking? Totally lost myself. Okay, vertex where x is -2 and y is -1. Okay, the axis is x equals -2. Okay, the function is decreasing over here, so I would say decreasing where x is less than -2. Because as I go left to right, I'm going down. The function has a negative slope. And it's increasing when x is greater than -2, right? Because it's got a positive slope. Or I could say that as I move left to right, the graph is going up. And the minimum value here is going to be -1. All right. That's all 20 of the problems for the homework. That was a lot of good practice on completing the square in vertex form for a parabola. If you're still feeling a little shaky on the completing the square, don't worry. We got lots more practice on this coming up throughout the unit. It's a technique that we'll use And not only in this unit, I'm not remembering where, but I'm hearing from my Algebra 2 co-teachers that we're going to need to complete the square elsewhere in this class, so you'll have more practice. Okay, thanks for watching. Hope this helped.